everybody. So today we're going to be talking about similar triangles. There are a few different ways where you can determine if two triangles are similar. We're going to talk about those. We have angle-angle, side-side-side, and side-angle-side. So our first similarity postulate that we're going to look at is called angle-angle similarity, or AA. There we go. So basically, with angle-angle similarity, if two angles of one triangle are congruent to two angles of another triangle, then those two triangles are similar. Okay, so if two angles are congruent, what that might look like. So we have here, angle A is congruent to angle F, and we can tell by that little tick mark. Angle B and G are congruent, so we can determine that our triangles ABC are congruent, or similar to FGH. You guys might notice that ABC looks a little bit bigger than FGH, which is okay. We don't want them to be the exact same because with angle-angle similarity, it's okay if they're different sizes. We want to focus on the angle measurements. Okay, so let's look at an example of angle-angle similarity. So here for our first example, we have JKL and triangle MPQ. Okay, with angle-angle similarity, we need to make sure at least two angles are congruent. So JKL, we have 48 and 57 degrees. MPQ, we have 57 and 75 degrees. I'm going to highlight my similar or my congruent angles here, okay? But we need to figure out what this missing angle is here and possibly here before we can determine whether these are similar or not. So, knowing what we know about triangles, a full triangle is 180 degrees, okay? If we're using up two of our angle measurements already, we can subtract from our total triangle angle measurement to determine what would be left. So, I'll say 57 plus 48, which is my two angle measurements already there, is equal to 105 degrees. If I subtract that from my total triangle, I'm left with a 75-degree angle measurement for K. And look here, 75 degrees for K, and then P is 75 degrees as well. Knowing our angle-angle similarity postulate, we can state that because angle L is congruent to angle M, and angle K is congruent to angle P, then triangle JKL has to be similar to triangle QPM. And I color-coded the specific letters of the triangle for you so that you know which vertex or vertices correlate or correspond. Okay? So these two are similar because we have two congruent angles. Looking at our next example, we have two triangles here. They look like they're pointing towards each other. We also have these little triangular marks on each end of our triangles. Okay? What these little markings mean, if you ever see these on two sets of lines, that means that you have parallel lines. Okay, so I'm going to extend out my line a little bit so that it looks like I have actual parallel lines. Those are called your auxiliary lines. And then I'm going to say, okay, well, RW, if that extended out as well, it looks like we have two parallel lines and they're being cut by this transversal. Okay, so I'm going to look at the interior angles of my triangle, okay, and see how they correspond to this transversal or these parallel lines. All right, so we think outside the box a little bit in this aspect. So I see here angle R lies along this transversal and it's inside of my parallel lines. Okay? Angle W also lies inside my parallel lines. Knowing what I know about parallel lines in a transversal, I know that by the alternate interior angle theorem, postulate, angle R and angle W must be congruent. Okay, so angle R is congruent to angle W, and that's by alternate interior angles, okay? Another thing that you guys might notice is if you're looking at your triangles, okay, we have these two angles created here by the points of this specific vertex S. Anytime you have two vertices, all right, that create that X, okay, the mirroring angles are congruent as well. Okay, so angle S is congruent to angle S, and those are vertical angles. Okay, so vertical angles are congruent. So now we have two triangles with two congruent angles, which means our two triangles are similar. So let's write that similarity statement. Remember, similarity statements, you have to have your corresponding vertices in the right places. So we're going to say triangle X, SR, okay, is similar to triangle T, S, W. And again, they are color coded for you so you know which angles go with which. Okay, moving forward, we have two more similarities that we need to look at. So we'll look at one similarity, do the example, look at the other similarity, and then do that example. So we're going to do one theorem at a time. So first we have our side-side-side triangle similarity. What this means, it's much like our congruency of side-side-side. However, with the similarity aspect, if your corresponding side lengths of two triangles are proportional, then the triangles will be similar. So what does it mean that they're proportional? Imagine these numbers were already here. If angle or side length JK was 8 and MP was 4, LK is 6, QP is 3, and then JL was 4 and MQ is 2. Remember, when you're working with proportions, you want to compare the corresponding side lengths. So here we have our red sides. 8 over 4 would be 2. 6 over 3 would be 2. And 4 over 2 would be 2. So creating those ratios, we have a similar proportion. Since all three sides are proportionate, then we know that our triangles JKL and MPQ must be similar. So let's look at an example of side-side-side similarity. Okay, in our first example, we have again these two kind of mirrored triangles. We can tell by the angle or the side measurements that this one's a little bit smaller than this one, but we need to double check everything. So we're going to start off by looking at our sides that are kind of cut. So we see PS, this big line, is cut a little bit by QT. So we're going to use this vertex here as kind of our little marking for the difference between the two triangles. Okay, so PR and RS, let me do that in purple. If we were to compare those, we have PR over, we'll say SR, because we ended at that vertex, would be a total of 8 over 20. If we reduce 8 over 20, we get a total of 2/5. Okay, let's look at our other sides. We have QR over TR. Okay, so QR over TR is 5 over 12.5. When you reduce 5 over 12.5, you also get 2/5. Okay, and then last but not least, we have PQ over ST. So PQ over ST, that is 6 over 15. Reducing 6 over 15, we get a total of 2 over 5. So we have three corresponding sides that are all the same proportion. Since all three are proportional, we can say that triangle PQR is similar to triangle Okay, so the way I wrote this statement, I went from one point to the next. So purple to blue, that pink to blue line, PQR, STR. Okay, so that is our side, side, side similarity. Okay, last theorem for the day, we're going to be looking at side angle side similarity. So like side angle side congruence, we're looking at two sides and an included angle. Okay, but in this one, if the lengths of two sides are proportional and your included angle is congruent, then you'll know that your triangles are similar. Okay, so like before, proportional, we're going to say RS, if this is theoretically 3, okay, and XY is 12, then in order for them to be proportional, ST would have to be, say, let's say 5, and then YZ would be 20. Okay, so if you create those ratios, we have RS 12 wrong one. 3 over 12 equals 5 over 20. If you were to reduce both of these, we have 1/4 equals 1/4. Okay, so our sides are proportional, and then we have this included angle, which would be congruent. Okay, for it to be congruent, we could say this is a 65-degree angle. This would have to be 65 degrees as well. So with side angle side similarity, we have two proportional sides, proportional corresponding sides, and a pair of included congruent angles. That congruent angle has to lie within the two proportional sides. Okay, so looking at an example, down here, you guys might notice that we have two triangles, one on top of the other. Okay, so AEF would be one triangle, ACB would be the other triangle. So we're going to kind of take this triangle apart and see if they are similar or not. So first I want to look at this angle right here. We notice that there's an A in the small triangle and the big triangle. Since that vertex or that angle is the same for both, we can say that it is in fact congruent. Okay, that's our reflexive property. Right? Now let's take apart our little side lengths. So here we're given AE is a total of 8. Let's compare that to the longer counterpart, AC. Okay, AC, you'll notice, is the side length AE of 8 plus 4 more units. So AC will be 8 plus 4, all right, and AE was 8. So here we have 8 over 12, okay, which would give us a proportion of 2/3. Okay, so let's look at the other side lengths they give us. We have AF, okay, that's a total of 10. And then we also have AB, which is 10 plus 5 more. Which gives us a total ratio of, wrong number, 10 to 15. And when 10 over 15 is reduced, we have 2/3 again. So let's look at the information we have just from this set of triangles. We have a set of congruent angles, right here, angle A. We also have two proportional side lengths, AC and AE, and then AF and AB. When you compare all of this information, we have two proportional sides and an included angle. Okay, so because we have two proportional side lengths and the included angle is congruent, then we know that triangle EAF would be similar to triangle CAF by our side, let's switch that to black, by side angle side similarity. Okay, so go ahead, start working on today's practice assignment. Let me know if you have any questions. Good luck.